So the first thing that we're going to take a look at is this idea of secant lines specifically with angles. And I cannot stress enough to you to remember to make sure that you're taking down notes. There's going to be some important vocabulary in this lesson. There's going to be some equations, some diagrams, and then of course several examples. So make sure that you are getting those down either in your notebook or in the guided notes student sheet that is posted there in Canvas for you. So as we start this discussion on what are called secant lines, the first thing we really need to discuss is what are they? Okay, so make sure you're getting this description down. Remember that we've talked about chords, we've talked about tangents, and so secant is different than both of those. A secant line is one that intersects the circle at 2 points. So you'll see that unlike our tangent that kind of hits our circle in one spot in that point of tangency and then continues on, a secant line is going to intersect 2 times. Okay, so today we're going to look at properties with these secant lines. There really are 2 types of secant lines that we could have. We could have secant lines that are intersecting inside of a circle, and we could have lines that intersect outside of a circle, and they have slightly different properties, slightly different equations. Okay, the measure of an angle formed by 2 lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. Okay, what that means is if I know this angle or this arc right here, and I know this arc, we'll call that one y, and I'm looking for this angle, angle 1. What it means is that the measure of angle 1 is going to be equal to, when we add those 2 arc measures together and divide it by 2. Okay, the measure of the angle is equal to the sum of those 2 arcs divided in half, or the half of the sum of the measure of the arcs. Okay, oops, this is supposed to be a 1 here. Just make sure you're really clear on a 1. Okay, so that's what happens if they're inside. Now we're going to look at examples here shortly, but I want to make sure that you have both of these equations written down. The other option is that they could intersect outside of the circle. Okay, so the measure of an angle formed by 2 lines that intersect outside a circle is half the difference of the measure of the intercepted arcs. Now you'll see that in this situation, there's 3 different diagrams that I've drawn here. Notice that we have different types of lines. This one is a secant, right? Those lines are both secants. Here we have tangent, right? It's 2 tangent lines that are intersecting. And then this one down here in the corner, we actually have a tangent secant. So there's really three different situations that we may have. But if we're looking for, again, the angle, okay, if we have, maybe say that this arc over here is x, and this arc here is y. And we're looking for this angle right in here. We're going to call this angle 2. Our equation, our property, is telling us that the measure of angle 2 is equal to x minus y divided by 2. Notice it's a little bit different. Here, when it's inside, we have that plus, and when it's outside, we have that minus. Now, the reason I draw all three of these situations here is because you're still going to use the same equation. It might just look different for different situations. So here we have an x and a y. You can still use that equation here. Here we have, here's our x, right? Goes from point to point, and our y. And we still can find that angle too. Okay? All of these situations use that same equation, that the measure of the angle when they intersect outside is x minus y divided by 2. So let's take some time and look at some examples. Okay, so let's label what we know. If the measure of AD is 155 and the measure of BC is 61, we want to find what this angle is here. Now you'll notice that this is an inside intersection. And when it's inside, remember that we said the measure of angle 1 is equal to x plus y divided by 2. So we're going to take these two angles and add them together and then divide them in half. So this will be 216 divided by 2. We're going to find that this angle right here is 108 degrees. Okay, so we can use this equation, noticing that they intersect inside, and find the measure of that angle. Okay, notice this one intersects outside. And in that case, we're told that the measure of angle 2 is x minus y divided by 2. Now, our x is always our biggest one. So we're going to write 151 minus 139 divided by 2. So it's 22. Divided by 2. We're going to get 11. Okay, let's keep going here. Now, notice here we're given a little bit different information, but we know the same equation. So we know that the measure of angle 2 is equal to x, which is the bigger one, minus y divided by 2. So let's fill in what we know. Okay, so we know that equation still works. We need to fill in what we know. We know that our angle is going to be equal to 34. X is always our larger arc, so that's 6x plus 6, minus y, our smaller arc, in this case is 3x minus 5, all divided by 2. Now I want to kind of start to simplify this, start to use some algebra on it. So 6x minus 3x is 3x, and 6 minus a negative 5 is 11. Okay, so now it looks like algebra. We need to keep solving this in order to find that x value. At the end, we will find that x is equal to 19. So we've used this equation because they intersect outside of the circle, and we're able to solve for an x. I want you to still see some more examples. I would encourage you to write these down, but if you have these couple in your notes and you feel good about it, these are kind of some extra ones to see. Okay, so we know our angle and we know one arc. Now remember, these intersect inside our angle, which means it will be x plus y divided by 2. Now let's fill in what we know. We know angle 1 is going to be 107. We know that one of our arcs is 74, but we don't know the other one. So we need to solve for that other arc. So then we know that this arc right over here has to have a measure of 140 degrees. Notice we're still using that same equation and just plugging in what we know. Here's another one. We have outside of the circle. We want to find this angle. Now you'll notice in this one we're missing this arc right here. How can I find this arc? Yeah, our whole circle has to be 360. So let's find what we're missing there, right? Well, we're going to take 152 away from it. And then we're going to take 126 away, and we're going to find out what we have left. So we know that this must then be 82, right? All three of these together have to add up to 360. So once we know that, now we can set up our equation. We know that that outside angle is going to be the big arc minus the little arc divided by 2. So we're looking for this angle. We know it's going to be 152 minus 82 divided by 2. Which will be 70 divided by 2. So our measure of the angle is going to be 35 degrees. Right, we're still using that same formula for when they intersect outside. Let's look at one last one. Now, this one has a lot more words, but we still know the information. So we know that these are perpendicular. We know that this arc BD is 126. We want to find this measure here. So these intersect inside, which means that we're going to add those two together and divide it by 2. Now we need to fill in what we know. This is perpendicular, which means it's in 90 degrees. So 90 degrees is equal to 126 plus something we don't know divided by 2. We can use our algebra to find that missing arc. We find that this measure here has to be 54. Okay, so this is our first section on secant lines, looking at those equations to deal with intersecting secant lines inside and outside of our circle. Oh, I didn't want to go that far. And so make sure that you have these two equations written down. Those will be really important as you're going through the practice.